Hello everyone, welcome to lecture 8. Today I will talk about Matplotlib and Seaborn. In general, we talk about the visualization in Python. Then you can use these two modules to draw your figure in the Python. And this is so related to the assignment 4. Assignment 4 will be released today, and then the deadline for the assignment 4 is the next Tuesday. For this assignment, we don't have any autograder, so you need to submit your code to assignment 4 code. And also for question 2, 3, and 4, you need to submit 3 plots that you generated by your code to assignment 4 written. And so I extend the deadline for assignment 3, and if you want, you can submit your code for assignment 3 until Wednesday. And if you have any question about the assignment 3, you can ask me by posting on Piazza. So let's start with Matplotlib. Matplotlib is a library for making plots in the Python, and Matplotlib is very flexible and useful in making plots. And most of the people that I know are using Matplotlib in their research, and then because the quality of the figures and the plots in the Matplotlib are so good, and you can draw various plots in the Python by Matplotlib. And also there's another library that is built on top of Matplotlib, for example, Seaborn. And the Seaborn has more functions, and maybe the figure that we can draw in the Seaborn is more fancy, and then but if you need to just use Python to make some simple plots for your research, you can use Matplotlib. So general workflow for using Matplotlib is at the first we need to create an instance of plot object, for example, plot, scatter, and anything like this, for example, bar plot. And then the Matplotlib consider this object as a general global object in your program. So for example, at the top of your code, you can get an instance of the plot object, and then try to make your plots on this object, and then the object that you just created on the top of your script can be considered as a global object, and you can have access to this object anywhere in your script. So for 1D plot, one-dimensional plot, for example, histogram, bar chart, you just need to pass a list or array. Then, for example, you pass a list, and then the histogram, the Matplotlib make a histogram of your list, and then you can save your plot, or you can have lots of lots of opportunity to change the style of the histogram. And for two-dimensional plot, you need to pass x values and then as an array and or list, and y values as another list. But obviously the size of these two lists should be same, because we need to have a y value for each x value that we have in a list. And you can if we have just one plot object, you can have multiple pieces of data and try to draw different plots or lines or histogram on just one plot object, and they will be plotted together in just one plot object. And in the interpreter, you can show plot immediately in a pop-up by calling just one function, which is show, and I will show some example of that. This means that if you are writing a code in command line and then you want to see the plot that you just built on the Python, you need to enter plot.show, and the command line show the plot immediately in a pop-up window, and then you can close the pop-up window and then continue on the writing code. And then you can also save the plot to the file or directory, and then use it in other in your document or any else that you want. So let's just start with an example. I think this is a simple example. We're using Matplotlib to plotting a line. So just as a NumPy that you need to import NumPy as an NP, you need to import Matplotlib dot pyplot as a PLT, which PLT is the name of this library that can be easier to use in your program. So pyplot is a function that is a module in library of Matplotlib that we can use to draw a line or any other plot that we will need to draw. So here we import in the first line we import matplot, and then because we are writing because we are plotting a line, we need to have a x and a y value for every point that we want to have in the plot. So we just create a NumPy array by linspace function. So -1 is the start point, and then 1 is the end point, and we have 100 points between these two, and then we generate that. So the length of x based on this function is 100. And then the y value is the x squared, which means that we get every element in the x and then square that and save in the y. So in this case, that we make sure that the size of x and y are the same. Then to make to plotting a line, we need to call a function from pyplot, which is the dot plot, and then parentheses, and then passing x and y to this function. And then now we just create the plot, and then if we want to show the plot in your program, and then we need to call a function which is plt.show, and this function just create another window and then show the plot that you just made. So if you want to show the plot, you can call this function, and this is the result. And then the plot function has lots of optional parameters that you can pass to this function. For example, you can change the style of the line or the color of the line, and lots of other options that you can change them. But passing x and y is necessary to plot a line. So we have some other kind of plots that we want to making in the Python. So for example, most type of plot. For example, we want to generate a scatter plot. So in this case, the workflow to generate this plot is same as before. And so for example, here we want to plot a scatter, and then for doing that, same as before, we need to pass x and y, which are array and list with the same size, to this function. So same as before, we have 100 numbers between -1 and 1 as a x, and then we generate y values by 2 multiplied by x, and then plus 6, and then plus random number that we generate by rand m, which is a function in the numpy random number generator, and then we pass 100 to this function, which means that we want to have 100 numbers in normal distribution. And I'm not sure about the 100 here. Yeah, I think this can be the mean of the distribution or the number of random number that we need in the output. So here I think it's the 100 is that the number of points that we want to generate by random number generator, and then we multiply it by 0.5, which means that we want to generate numbers by standard deviation of 0.25. So anyway, you can change the formula of y here, and then it doesn't matter. The only thing is matters that the size of y should be the same as size of x, and then we call another function we have in the matplot, which is a scatter, and then pass x and y to this function, and then same as before, we need to call another function, which is the plt.show parentheses to show the plot. This function actually tells the Python to show the plot that I just created. If you don't have plot.show in your program, the Python does not show the plot to you, but actually we have the plot in the program. But if we want to see the plot, we need to call this function. So as I mentioned, you have to call show or save fig to actually run the plot. And actually, the show function pause the program and then execute the pause program execution and to show the plot. So this means that if you have if you are plotting a figure in the Python, if you call plot.show, the interpreter pause the program and pop up a window to show the plot to you. And then if you close the plot, if you close the window, you can continue on implementing other line of your code. So also for this, I just show an example here to show how the interpreter pause your program. For example, here we have a terminal, and then we have x as a 100 number between -1 and 1, and then y is defined based on the previous formula that I showed, and then we call plot.scatter and then pass x and y to this function. And finally, at the end of the line, we call plot plt.show. So after calling this function, the Python open a window, which means which the title of window is figure 1, and show the plot to you. And if you want to resume the program execution, you need to close the plot window. For example, here we can click on this sign on the top of figure and then close the figure to continue on the writing program. So another way to display the plot is the save fig, and then this function actually saves the plot into a file with a specific name. For example, here we after calling scatter x and y, we want we have this scatter, but the program will not show the plot yet. And if you call a function which is the save fig and then pass a name to this function, the Python and Matplotlib actually will be saved the image in a current directory, and you can go to this directory and open the myscatterblock.png, and you can save your plot with different format. I think actually PNG and JPEG is PNG and JPEG are most popular format of saving image in Python, but you can check this function to see how what are the other options to save your image in the directory. Actually, what are the option for the format. So if you want to have just one figure with different plots, you can do that in the Python. You can plot multiple set of data in just one plot window, and then I will show some example of that. But for example, you have two data. For example, y1 and y2, and you want to plot these two lines in just one plot. You can do that by calling, for example, plot.scatter and then pass x and y1, and then another plot.scatter x and y2. And then after that, you can call function plt.show to open the new window, the plot window. But this can just open just one plot window instead of two. This means that you can plot multiple set on just one window. That's an example of that. For example, here we have x as a before, so we have one set of data which called y1 with this formula. And we have another x that is 10 numbers between 0 and 2, and then we have a y2, but note that the y2 is based on x2. This means that to say that the size of y2 and x2 are same, which is 10, and then we have 100 number in y1 and x1. And then we call the function scatter and then pass x, y, and y1, and we call another function, not the same function but different parameter. And then after these two lines, we call plt.show parentheses. And as you can see, we have two multiple lines in our plot, and then with different color. Coloring the line function in the matplot is automatically, and then you don't need to pass the color to that. The matplot show lines in the plot by different color, and you can choose a specific color for a specific line in your plot by passing the color to this scatter function. But if you don't add, the matplot choose the color automatically for based on the number of lines that you have in the plot. If you have 3, I think the next line will be plotted by green color, and then you can add lots of data to this color, to this plot, and then the matplot choose different color for different lines. And if you plot some things, then you call save fig. The plot so if you have different line in your plot, and then you want to save the plot that you just made in a directory, you can call save fig as before, but you want to be careful about that, because if you call save fig and then plot some other things after a line that you call save fig, the the plot change over time until you call another function, which is plt.clear figure parentheses to, and then this means that until you call this function, you can plot another line in your figure, and then save it to the directory by calling this function. If you want to make sure that the previous figure that you create doesn't change anymore by your program, you need to call this function, which is plt.clf parentheses to clear the figure, and then make sure that the previous figure doesn't change. For example, here we have x1, y1, x2, y2, and then we want to save this plot in test1.png, test2.png, and test3.png. So after calling scatter for x1 and y1, we call another function which is save fig to save this to save this plot, and then we call another function and the same function with different parameter x2 and y2, and then we called the plt.savefig to with this name that we have for this figure. But as you can see, if because we don't call plt.clf parentheses before that, this means that the Python continue on changing the previous plot that we had, and then this is the test1.png, but you'll have this previous data on test2.png, and then the new data that we just passed by x2 and y2 to this plot function. So, but as you can see, the range of x value and y value change based on the new data that we just add. But if you don't want to have the previous data in your new plot, you just need to call a function plt.clf parentheses, and then this means that we just clear the plot object, and then we have another scatter by passing these values, and then we save the test3.png, and as you can see, test3.png just have the new data that we just add to the plot, and we don't have the previous data. So if you don't want to have the new data in your plot, you need to call this function plt.clf parentheses. So there are other function for the matplot, and for example, fixing a title for your plot, or you need to assign values for the x label and y label, and then for example here we plot a line by passing x, y, and y1, and we want to have a title for the figure in the output. So you can call a function which is plt.title, and then pass a string to that as a title for your figure. You can also use two other functions, which is x label and y label, to set values for, so set strings for the x label, and then x axis, and then y axis. So if you want to have a legend for your figure or plot, you can do that also with Matplotlib, and by calling just a simple function which is plot.legend. And this function show a box on top or left down of your figure, and then you can see that, for example, we have a label for the second data that we had in this plot, which is another process, and then you can have this legend in your figure by different color, and then to make it specify which line is the label of the each line in your figure. But you need to be careful that you just, for using a legend function, you need to pass a argument to plt.plot, which is the label, and then specify a string for your data to use in the legend that we have in the figure. So this means that if you have label for your data and then calling a plt.legend parentheses, this can add a legend to your figure, and then I think legend has the other option argument of the argument optional argument. For example, you can specify the location of the legend in your figure. You can set that you need the legend in the top left or top right or down right or something like this. And because sometimes the legend has a conflict with the line in your figure, so you need to specify the exact location of the legend in your figure to make it clear for showing to other people. And you can also change the X ticks and I think Y ticks in your figure. This means that we have just one simple line in our figure, and we want to, instead of having the all values that we have in the x1, we want to just have three values in the x values that we have in the figure. For example, here we just mentioned that we call the function xticks and then pass a list to that, and then as you can see, we just have these numbers in this line in this axis, and then we call function plot.show to see the output. And as you can see, we just pass a list of numbers as xticks, and then I think yeah, we can have a string or name for xticks, and then you can pass another list which has the same size of the first list, and as you can see in x's and x's, and we have these strings or names that we have in the second list. Mostly we need to have these kind of naming in the x-axis, and then because our data are categorical, or we are using just classification or something like this, and we want to specify the name of the class or the name of the category that we are showing in the figure. So in this case, xtx can be so useful for doing that. So these are some useful function in the Matplotlib that we can use to draw figure. Another part of the Matplotlib which can be so useful in the plotting is the subplot. Now, the subplot actually is the subcomponent of the one just plot that we have. And as you saw, the entire window that we the Python pop-up in your program is called figure, and each plot that we have in just one figure is called subplot. And for example, if you need to have two figures side by side in your for example, in your research or in your document, you can use subplot to make it just one plot with just one figure with two subplots. And so this means that we have just one figure with multiple subplots, and we can do that with the access and dot function, because before we used plt dot function to show something in the figure, right? And instead of that, in subplot, we have access that function to have different subplot. Let's an example in that for subplot. For example, here we have a function in the Matplot which is subplot, and then we can pass the number of rows and the number of columns that we need in the subplot. So for example, you can assume the subplot as an array which has number of rows and the number of columns. So in this case, we specify that we have 2 rows and 2 columns, which means that we need 4 subplots in just one figure. So after that, the plot.subplot return 2 variable to you. The first one is the figure, and the second one is the axis. And then by axis actually is a array that you can access each element in this array by specifying the index. For example, for the first figure in the left, in the left, you can have access by calling 0 and 0, and then pass a function to that, which is not calling the function, which is the dot plot, and then pass x, y, and y1, which are the birth data that we have here. And as you can see, we have another subplot in position 0 and 1, and then pass data to that point, to this position, which is these data x2 and y2. And So this array access actually provide useful function for you to modify your figure. For example, you can have different label for x and y axis in your subplot by calling this function by this object that you have for the first axis. And then in the output, you can see you just have one figure with 4 subplots. And that can be so useful in some, for example, if you want to compare different data side by side in your document, you can use subplot to do that. And another useful figure or plot that we can have in the Matplotlib is error bar. And for example, you have just one line and you have your own error for your line. So in this case, you can call a function which is error bar to show the error for your line in the plot. And as you can see, you just need to pass x and y to this function, and then for the y error, you need to pass a list of the numbers that are actually the error that we have for the y values in this figure. And for example, here we have 0.1 error for each values that we have for in the y values. So I think x1.size return 10 because we have 10 numbers in the x, and this means that we need to have 10 error bar in the figure, which is true. And so actually this list that we are passing to this function, the size of this list is the 10, and for each for each value that we have in the x, no, for values that we have in the y, we need to pass error bar, which is the 0.1, 0.1. So sometimes you need to have error bar with just your data, but because we want to have a simple example here, we just pass 0.1 for all data that we have here. And another type of useful figure that we can plot in Python is the histogram. And the histogram allow you to visualize the item frequency in your plot. For example, you want to know how many students are getting A minus or A in a course. You just need to pass a list of grade of students to the histogram in the Python. Then histogram show the number of students that get, for example, A or A minus as a histogram in a figure. So this also is so useful for understanding the distribution at a high level. I will show some example of that. And it's important to note that the input space, for example, if we are passing a list to this function, the input list, the input space is broken into a fixed size of intervals. And for example, we have a list of numbers between 0 and 10. I think the histogram plot the beans in the matplot actually plot the histogram with the number of beans that we want in the output. But if you don't mention the number of beans in the histogram, the matplot automatically define the number of beans in your histogram and then try to draw that. So for each interval, we plot a bar and then show how many items are in that interval. This is the definition of the histogram actually. For example, here we just generate 1000 random number with using a normal distribution with calling this function. So the size of x is 1000, and then we use the function hist from Matplotlib to plot a histogram on this data, and then pass the x and then the number of bins that we need. For example, here we need 100 bins, which means that the matplot divided the x values actual the input size between 100 bins, and then count the number of times that we have the numbers, the number of items that we have in just one interval, and try to plot the histogram. So as you can see, this is actually a normal distribution. Is similar to normal distribution. If you increase the number of points in this function, that can help to have a more similar distribution to the normal distribution in the output. So if you have just 10 or 20 numbers, the histogram is not similar to normal distribution, but because we have 1000 numbers here, it helps to have a kind of similar normal distribution in the output. Also, there is another optional argument that you can pass to this function, which is density, and then we say that the value of the density should be true. And then, as you can see, that the histogram doesn't change, but the range of y values change here because the matplot tried to make a probability density function for each interval, and then before that we have the numbers that we have in just one interval, but here we have a probability distribution or a y values. So if we change the number of pins also, here, for example, we mentioned that the number of pins for the output should be 10. And as you can see, then in the output, we have just 10 or 10. I think we have 10 bins in the output. And then the so because we have less bins in the output, and this means that the the numbers that we have in just one interval should increase. So as you can see, for example, 250 times we have x values in these pins, and also other numbers for other pins. So this was the introduction of the matplot, but there is another library for plotting figures in the Python, which is Seaborn. And then I should mention that the Seaborn is built on top of Matplot, which means that you can have access function in the Seaborn from Matplot, but you can have access to other additional function to make your plot fancier in the Seaborn. So this means that the Seaborn has a wider variety of plot types that we can plot in Python, and usually it's easier to understand the syntax in the Seaborn, or it's easier to pass argument to the function of the Seaborn, and I mentioned before that maybe the style that we have in the Seaborn for the figure or plot are nicer, and then or fancier. And also for before that, we show that we can pass array and list inputs to the matplot, and the Seaborn actually support this kind of data. This means that you can pass array and then or list to this data, but also you can pass data frames from pandas as an input to this library, which make it easier to use Seaborn with pandas. In the Seaborn, we have lots of functions that we can use to plot. One of them is the bar plot that we just saw an example in the Matplot. And actually the bar plot in the Seaborn can show the count of discrete items, and also that you can use bar plot in the Seaborn to use to have a discrete input and then continuous output. Let's see an example of that in the Seaborn. For example, we as we have in Matplot, we need to import Seaborn, and then we need to select one name for this module, and for example SMS, and then Seaborn has a function which is the bar plot, and then in this function you need to pass two lists. The first one is the x, and then the second one is the y. And for example, here you can see for the x we pass a list of the string, and for the second list, for example numpy array, we passed a numpy array with discrete integers or integers that are used for discrete items. For example, here we want to know that how many fish or how many chickens we have, and we want to have in the bar plot by Seaborn. And so because as I mentioned before, the Seaborn use Matplotlib to as a base. And so, for example, if you want to show a figure in the Seaborn, you also need to call this function plt.show. This means that in your program, if you want to use Seaborn, you already import the matplot in your program, in your script, and then as a plt, and then call a function of that, which is the plt.show parentheses, and then plt.show draw the plot that you just made by Seaborn, and which is like this. In x-axis we have the name of animals, and then in the y-axis we have the number of animals that we have. So you can see our values for in the y-axis are discrete because we passed integer for that. And if we want to pass continuous values to this bar plot, we can do that with this function also. So I mean the continuous values that we want in y-axis here. And so let's an example of these continuous values. And for the input, discrete input, we have days of the week, and for each week we want to compute the total bill that we get for total bill or total tips that we get from the other people in the week, in each day. So here we have multiple continuous output for each day, and we want to plot the average total bill for each day with error bars. So if we want to show this figure in the matplot, that would be more harder than the Seaborn, but in Seaborn you just need to call a function bar plot. And before that, I should mention that we are using a data set. Sometimes you have an idea about a figure or plot, and you want to test that in your program with some other data set or other data. So in this case, you just need to use available data set, and then load data set by this function from Seaborn, which is SNS dot load data set, and then pass the name of the data set, and then we can call a function which is the bar plot, and then pass x and y values to this function. And then because Seaborn already know about the data, because we have the tips here as a data set, we can pass the data to we can pass tips data to the data argument in this function. And as I mentioned before, we need to just call a function from the matplot plt.show to show the figure. So in this case, we want to know that what is the total bill as a y, and then the day of week as a x in this data set. So I think we pass the objectives to the bar plot function of the Seaborn, and this data frame has two columns, which the first one is day, and then the second one is the total bill. And so if we just load the data set of the tip in our program and as a tips here, so tips is a instance of the data frame. So if we pass tips as a data frame to bar plot function, which means that this function extract the column named day from this data as a x, and then the total bill column in the data as a y, and then try to plot this bar plot. So this is the same code as before, and you can see the output here. And then we have the day of week: Thursday, Friday, Saturday, Sunday, and this is the total tips that we got from different day, and you can see that total tips are more than the higher than in Sunday compared to Saturday or Friday or something like this. This means that people give more tips in the Sunday or something like this. So in this case, you can see the result in the bar plot by error bar for each bar that we have here. So also I mentioned that the tips dataset that we just load is an instance of the data frame, and the data frame is a data type in the pandas and the Seaborn functions accept these data frames, which can be so useful to work in pandas and then use the data in the pandas or R programming, and then using these kind of data to plot in the Seaborn. So another example in the Seaborn is cluster map function, and the cluster map actually get the data and then visualize each row in a grid or heat map the plot, which color used to indicate the numerical values, which means that the color show that how much, for example, if we have a lighter color, means that the number of instances in this cluster are much higher than other cluster. I will show an example of that. So, and then the row our cluster, and which means that the similar rows in the numbers. For example, if you have rows with numbers, if we find another rows with similar numbers, we can cluster them together. And you can also group similar columns together if you want instead of rows. So here we just load a data set that we saw in the assignment 2, IRIS, and then we call a function from this data frame, which is the pop, means that we have a column in this data set name feeds, and then we extract this column from the data set, and then we store this column in this variable. So also I should mention that if you use pop, the original data set does not have this column anymore. So we just extract, and then we don't have anymore this column in the original data set. And then we call a function cluster map and pass the data frame object here to this function, and then plot dot show can show the figure that we just created by cluster map. So this is, as I mentioned, the Seaborn is more. You cannot plot this figure in the Matplotlib, and you just need to use Seaborn to have this kind of plot, which I think is more fancier than the Matplotlib. So as I mentioned before, this is a heat map, and then the color can be used to indicate the numerical values. For example, here we have a indicator to show that what is the value for each color in the cluster map. So the lighter means that we have much higher than much values for the lighter colors, and then the darker one has less values. So for each row, you can see the numbers here, and then for each feature that we had in the data set, you can see a heat map of that. And then also there's a part of figure here that show that the clusters of rows. This means that for example, this rows is close to the cluster of these rows, and actually this is hierarchical clustering that show that how much these rows are similar to each other, and maybe it's hard to explain the cluster here, but there is just one example to show how we can use this cluster map. So if you already know the data, you can use this function to cluster your data and then extract some knowledge from this figure. And we show some example from Matplotlib and Seaborn today, but there are lots of function and plot that you can implement in the Matplotlib and Seaborn. And there is a suggestion if you want to make a plot or draw a figure in the Matplotlib and Seaborn. I would suggest that if you don't know if you don't have any idea about the figure, you can go to some online example and then try to change the example code line by line to make it more compatible with your data. And I show some resources here for lots of example in the Matplotlib and then Seaborn, and there are lots of tutorial, and then you need to read them to make your example or make your figure with your data. And also there are lots of blog and Stack Pro posts about the specific things. For example, if you have an error in your the plot function, you can just search that and then go to the Stack Overflow or other blog, and there's I would suggest that you can go to this blog because there are lots of error that other people get, and then they find the solution for that problem, and you just need to search your error and then find the solution that the other people get. If I find so, also I want to show this example or that we have in the Matplotlib. You can find like a lots of examples of the figure here, and if you, for example, if you want to change, if you find that one figure is similar to what you are looking for, that you can just click on one of them and then find the code of that figures and try to make it compatible with your data. And I think there are lots of examples for the Seaborn here. You can see that the figures in the example that we have in Seaborn, maybe it's more fancier than the Matplotlib, but it doesn't matter if you just find that this figure is more compatible with your data, or you want these kind of figures in your document, you can just use these code lines and try to change that and modify that. And also, as I mentioned, there are lots of tutorials for making figure in the Matplotlib, and for example, you can change the color in the figure, or you can add a text in the figure. There are lots of tutorials for that, but I think the simplest way to use the figures in your document or your research is finding similar figures in Seaborn and Matplotlib and try to modify them. Hope this can be helpful for your research or your other courses in the Python. If you have other question about this visualization part in this course, you can ask me or send them post on Piazza. That's it, and bye now.